Hello guys, and welcome to the first video in the tutorial series on how to make Conway's Game of Life in Ruby. In this first introductory video we are going to go over the game's principles and rules. So what is Conway's Game of Life? It is basically a game. You probably did not think that, but it is a game. And the game isn't especially fun to play, but has become famous because it is fun to build and program. It is used to teach people programming languages and programming principles. If you go here on the Wikipedia page of the game, you can see its history, its examples, its rules, etc. But reading this is kind of boring, and I just thought that I would show you what the game looks like and what will hopefully be the end result of our tutorials. So if I just go to my terminal here and run my game, you can see how the game looks like. The Game of Life is a zero-player game, meaning that you just define the initial beginning state and then you basically press play and observe how the game evolves. The game board consists of a grid, as you can see. This grid consists of cells, which can either be alive or dead. The black dots that you see all around represent the alive cells, and the white squares which you see in between them represent dead cells. And these cells become alive or dead depending on 4 rules, which we are going to go over in a second. And these 4 rules cause the game to behave like you see here. Everything you see here is coded in pure Ruby. We are just going to be using 2 gems for this. One is RSpec for TDD, and the other is Gosu Gaming Library, which is responsible for this visual output. Okay, so now that we have a concept of how the game looks like, let's go over the game rules real quick. If you go to the Wikipedia page, you can see under here, under the rules, there are 4 rules, and we are going to see how these rules apply to our game on this lovely sketch that I've made here. This is a sketch which represents a grid of dead cells, and we are going to observe the rules on one specific cell. Let's say this one. Okay, so this cell represents our example cell, and it is a live cell. And this cell, as each and every other cell, has 8 neighbors. 1, 2, 3, 4, 5, 6, 7, and 8. And if we take a look at the rule number 1, the rule number 1 says any live cell, which is our red body here. So any live cell with fewer than 2 live neighbors, meaning 0 or 1, any live cell with fewer than 2 live neighbors dies as if caused by underpopulation. So if our cell, which is alive, has fewer than 2 live neighbors, meaning 0 or 1, in the next round of the game, the red cell is going to die. Okay, the next round is going to look like this. But actually, to clarify, the next round will kill both of these cells, because as this red cell has only 1 live neighbor, this gray cell, which is alive, also has fewer than 2 live neighbors, 1 live neighbor, and according to rule number 1, the next round will kill both of them, and will look like this. Okay, so that is rule number 1. Rule number 2 states that any live cell with 2 or 3 live neighbors lives on to the next generation. So if our example cell here has 2 or 3 live neighbors, this cell is going to live on to the next generation. So that is rule number 2. The next one, rule number 3, states that any live cell with more than 3 live neighbors dies, as if by overcrowding. So if this cell has more than 3 live neighbors, meaning 4, 5, 6, 7, or 8, whatever, as long as it's more than 3, this cell which we are observing is going to be dead in the next round. Okay. We are not going to observe what happens with these cells for now. We're just going to focus on our example cell. Okay, so that is rule number 3. And the final, rule number 4, states that any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. Okay, so if our example cell here is dead, but if it is surrounded by exactly 3 live neighbors, so if it's surrounded by exactly 3 live neighbors, this cell which we are observing is going to become alive in the next round. Okay, and these rules are basically all that governs the behavior of the game and causes these cells to behave as you see here. And this is basically it for the introduction. In the next video we are going to begin to create the basic file structure which is required for the game, and then we'll just take it from there. So thank you for watching, and see you in the next video.